This is Pythagoras, right? So this is
Pythagorean theorem.
the Pythagorean theorem, okay? Yes, and he was a very smart person. So you ever heard of this?
Dave.
Yes.
No.
Yes?
I don't know what it is. I've heard the word.
You've heard of that?
No.
Some people have, some people haven't. Okay, so this is really, really important concept. How important? You'll use this a lot in every single math class that you take. We've been doing this a ton in geometry lately. So in a couple years, you're going to use this again a lot. So major concept right here. You can only use this. And a theorem is another way sometimes of saying a formula. So you can only use this formula with right triangles. Okay? Everybody knows what a right triangle is.
Yeah.
What's that?
90-degree angle on that triangle.
90-degree angle, right? So this has to have a box. Exactly right. Okay. So we're going to draw a triangle, and I'm going to make it into a right triangle, and I'm going to try to make it as basic as I can. Okay, so here's my triangle, and then I'm going to put a capital A on the top, a capital B on the bottom, and a capital C at the box. And I don't necessarily have to write it this way, but it's going to be the easiest to kind of tell this concept by putting the letters in those particular places. So again, I can only use this if I have a right triangle. If I don't have a right triangle, I cannot use the Pythagorean theorem. And it's going to be a formula. Okay? Everybody okay with the formula? All right, so you're going to have certain pieces, and you're going to use those pieces to find something that's missing. That's the epitome of a formula, right? Okay, so the most important again is that we identify the box or the 90-degree angle, and then we're going to talk about words like this. Remember when we introduced or talked just a little bit ago about opposite angles, two sides? And I had my triangle that I had up here, and I was showing you the opposite angles to sides. I'm going to draw some kind of triangle, it doesn't really matter. But basically what this is saying again is the opposite angle to the sides is the side and angles that are diagonal from each other. That's what opposite means. All right, so this angle down here is opposite of that long side over there. This angle over here is opposite of that one. And this one is opposite to that. So remember when I was showing you the long side was opposite of which of the angles? The longest angle, or the biggest angle, right? Not the longest angle, the biggest angle. Okay, so you got to keep that concept going when we start talking about Pythagorean theorem. Right? So the other thing that you really have to start thinking about is, notice that all of my angles always have what kind of letters again? Capital letters. Okay? When we talk about the opposite sides to those angles, the letters are going to correspond. Have you ever heard that word? What does correspond mean? Like what?
Go with?
Yeah, they go with. Okay? So they're going to correspond with each other by the same letter. All right? So when we talk about opposite angles to sides, we know that angles have to be capital letters. So the corresponding sides that go with them have to be then lowercase letters. But they're going to correspond, so they're going to go together, so they're going to be the same letter. So if I have a capital A, the side opposite of it would be lowercase a, and so on and so forth. So capital B goes with little b, and capital C is going to go with little c. But this happens with any of the angles that you can name. So instead of using A, B, and C here, I could use X, Y, Z. I could use LMN. Okay? Any of those angles, they also have the same letters with the sides, they're just lowercase. That makes sense to everybody? So when we go and do the opposite part here, notice here, if I go opposite of this angle right here, which is capital C, what should this side be called? Lowercase c, right? And what should this side right here be called?
Lowercase b.
Lowercase b, because it's opposite or across from it, right? And then, so obviously the bottom side should be called
Lowercase a.
little a, or, again, now you could go back and you could use the two angles and write it as a segment. We kind of introduced segments the other day, didn't we? So you can do it either way, but a lot of the times they use these lowercase letters, and that's what we really want to concentrate on for this particular case. Does that make sense to everybody? Okay, so if we think about what we talked about before I started this part on the other assignment, and we said that the longest side was always opposite of the biggest angle and so on and so forth. What do I know about this kind of triangle right here? Because of the box, it has to be what? Right. And so we know that this degree measure right there has to be how many degrees? 90 degrees. And what do we know about all of the angles in a triangle? Okay, there's at least two acute, and they all what? Add up to 180 degrees. So if I have one that's 90 degrees, and Addie said they all add up to 180 degrees, what do my other two add up to? 90 degrees. And so, as Carson said, these are going to be two acute angles. Right? Any two acute angles that I want. So basically what we're saying here is angle A and angle B have to be acute angles. Can I ever draw a right triangle that has an obtuse angle in it? You can't do that, right? That was one of those that 30 through 34 on the assignment today. I think they asked you to draw a right equilateral or a right obtuse triangle. Can't happen. Right? I can never have something like this and then come back and have a 90-degree angle too. Because if I have 90 and 100, 100 plus 90 is already what? 190, and all three of them have to add up to 180. Okay? So, if my right angle is 90 degrees and the others two have to be combined 90 degrees, what's true about that right angle in this particular triangle? It has to always be the what angle? Yeah. So in a right triangle, the 90-degree angle is always the biggest angle. So if the 90-degree angle is always the biggest angle, what has to be true about the side that's opposite of it?
Must be smaller.
It's got to be the what? The biggest side. So let's write that down. The side opposite of the 90-degree angle, and when we say opposite, maybe we also say diagonal from. However you want to think about it, or your melon kind of thinks about it, is always the longest side. Markers are really sweet. Okay? So again, this is a really big concept right here too. Put big stars around that because that's really important. The right, or the 90-degree angle in a right triangle is always the biggest angle, so the side opposite of that has to always be the longest side. Right? Most of the time they're going to use A, B, and C. They do not have to use those for the three angles. They can use any letters that you want. So again, if we drew another right triangle right here, but instead of A, B, and C, we used X, Y, and Z. What is my, and sorry, come back and put my box there. What is my longest side in this case?
Z.
Z, right? The side that's opposite of that 90-degree angle. Everybody okay with that? So, from here now, we're going to introduce a word. So, the longest side in a right triangle is called. Now, anybody have any guess what this is called? Maybe you've heard this word. It begins with an H. That help anybody?
Second letter. Hybrid.
The hybrid side, no. So, this is called the, what's that word?
Hypotenuse.
Hypotenuse.
Close.
Okay? So again, this is really, really, really important. Hypothesis, hypotenuse, yeah. Hypotenuse. Okay? So the hypotenuse is always going to be the longest side. So we always know that the hypotenuse is opposite of what?
Long
The
side.
90-degree angle or the box. Okay? So in either of our triangles over here, the side opposite of the 90 degrees is little c or little z. And each would be called the hypotenuse of that triangle. Okay? Really important concept. All right. So, what do I call the other two sides of a right triangle? Any idea? What do I call this side and this side? They have the same name in a sense, but they're the what of the triangle compared to the
Oh my
hypotenuse.
gosh, it is the. I learned this.
You learned this. Not the hypotenuse.
It's like the line that you draw in between the triangle and then like you can pull it out like.
The line of symmetry.
So, I don't know if you've ever probably seen this. So this side right here and this side right here, we're going to call the legs of the triangle. Ever heard of that? Yeah. The legs of the triangle. So how do I know that they're the legs of the triangle? What would they do? If I put the legs of the triangle together, what do they form? Yeah. The legs form the 90-degree angle. Now again, this is one of those things that might come up when we take those ISAS tests next week, all right, as vocabulary. So just remember all that stuff. All right? So now we're ready finally to actually write the Pythagorean theorem.
Pardon this interruption, but I just wanted to let you know that some little leprechauns were spotted